Is it the same? No, not USB-C. Cheers, mate. Oh, yeah, go for it. No. Oh, no, but Wi-Fi. Wi-Fi, yeah. Okay, we're good to go? Need speaker notes? Can we make it bigger? Just bear with us a minute, the joys of conference AV setups. That'll do, yeah. Okay, awesome. Thanks for that, Peter. That was an awesome session. Before I dive into it, I just want to say how happy I am to be back in India. As Peter mentioned, it's been 3.5 years now since we were here last, so it seems like a lot longer with everything that's been going on, really. Good to see some familiar faces from the past 2 SUGCON events. Good to see some new faces here as well. Always good to be over here, though. So, what am I going to talk about today? Well, today I'm going to be talking about Sitecore Search. I'm going to talk about a project that we did in the developer advocacy team here at Sitecore. And this is a recent build that we worked on, so we're going to be discussing how we went through it and basically the outcomes of it. My name is Rob Earlam, and I've been working with Sitecore products for pretty much my entire development career, really. Working with Sitecore themselves for about 8 years now, and you can see a whole heap of different social things on there. I seem to have to add a new one every time I do a presentation at the minute, so let's see what arrives for the next one. What am I going to talk about today, though? Well, I'm going to be talking a bit about the developer portal. This is where we integrated Sitecore Search recently, and we got a lot of success out of it, so I'm going to show how we integrated it in there. I just want to call out straight away, though, that everything I'm going to show you today is already live. You can go to developers.sitecore.com, and you can see all of this in action. You can try it all out for yourself. Yeah, so really nice to have a live example to talk you through. Before we go too much into Search itself, though, I do just want to talk a little bit about why Search was a good fit for the developer portal itself. And the developer portal at Sitecore is an interesting use case because we actually have a heap of different content repositories out there. We've got things like the documentation site, we've got a lot of GitHub repositories with open source coding, we've got our Discover Sitecore YouTube channel, we've got a Sitecore Stack Exchange, we've got the community forums, we've got all these different repositories of really valuable information. And we created the developer portal a couple of years back now as a way to kind of bring all that together and to kind of act as a directory of all of it. So the aim being you could go to the developer portal to locate the different content across these different repositories. What that means is that most of the content on the dev portal isn't actually hosted on it. Most of it's hosted on other sites that are owned by Sitecore. So it becomes this kind of shooting off point where you'd go to the developer portal, try and find out what you're interested in, and it'd take you to a different location where the content actually exists. We did have a search implementation on the dev portal, which it was okay. It kind of did the job, but when Sitecore Search was released earlier this year, we realized that that was going to be a much better fit for what we wanted. So we got together and we started to think about how we wanted it to work. And we came up with this idea that we basically wanted the user to come along and be presented with this search bar, very similar to how you'd see in a lot of websites. You enter the terms you're interested in. For example, this user's looking for how to migrate from XM to XM Cloud. You then click the little magnifying glass, or you hit your enter key, and then it goes and performs a search across all of these different content repositories all at once. This is what Federated Search is. It's the ability to search content from a variety of different sources and have all the results returned in a single data set. So it combines all these different content sources to one set of data that then you can refine on, you can page through, you can interact with, but you're getting results from across all these different locations. Obviously, we don't do all this live. We can't go and call these different sites as you search, because that'd be really slow. So what Search does, when you set up each of these sources, it'll actually go and index all of the content that's stored on there, and it stores all of those in different indexes in the back end of Search. So when you go and you use this search box and you interact with it, you're actually interacting with those search indexes, not with those target sites themselves. And that's how you can get searching across like heaps and heaps of content sources, but a really, really fast response time. So how did we end up actually implementing it? Well, the first kind of way it's been integrated into the dev portal is through this preview search widget. And this is the first way you're going to interact with it. The idea is really to kind of quickly surface content to the users as fast as we can. So for example, the user here is search for XM Cloud. And you can basically see there's two different types of suggestions being made. If you look on the left-hand side with the blue background, you've got suggested terms. So what the AI on the back end is doing here is trying to add an extra search term to your key phrases to help narrow down the search more, to get you to what you're looking for quicker. So it's suggesting maybe you're looking for the XM Cloud FAQ. Maybe you're looking for XM Cloud embedded, in which case you're probably looking for embedded personalization. Again, the aim trying to narrow down the amount of content that you're looking for here. On the other side, with the white background, you can see the current top 6 results that match the key phrase that have been entered. And the idea again here is to try and get the user to the content they're looking for as quickly as possible. So you may find that, when you enter your key phrase, the preview search will appear, that what you're looking for is there right in front of you. You can click on it and be taken straight off to that result. And that's fantastic. We've had a great result there because the amount of clicks it's taken for you to get to where you want to be is really, really low. Obviously, we're not going to hit gold every single time. Sometimes you're going to have to do a full search. So as we said, you click the little magnifying glass or you hit enter, and then you're taken through to the full search experience. So at this point, you're basically interacting with a search page, which a lot of us will have seen across many sites. We've probably built some very similar in using like Solar, maybe even Lucene if you've been around a little longer, in XM and XP. The nice thing about this, though, is all of this is controlled from the back end of search, which is called the Customer Engagement Center, or the CEC. So all the facets you can see there, they're all controlled from the back end. So if the marketer wants to go in and create an entirely new facet or change the values in the facets, they can do that. The sorting on there, all controlled from the back end. So if a marketer wants to go in and create a new way of sorting, if they want to remove one of the existing ways of sorting, again, they can control all that for themselves. No developer needed to get involved, so it really enables the marketer to take control of these search experiences. Okay, so let's take a look at this in action. Can we jump back to the demo? Okay, awesome. So this is the Sitecore developer portal. There's a lot of developers in the audience, so I'm hoping you've seen this you've seen this before and this isn't the first time. But when you come along, you get this search box that I mentioned. And if we click in it, we'll see we get our preview search rendered out for us. At the minute, we've not given the AI anything to go on. It's a complete shot in the dark. There's no key phrases there. So really, you're not expecting it to come up with the content you're looking for. It'd be a bit of a fluke if it did. But we're going to start to help it out. We're going to start to help it help it try to think about what it is we're looking for. So what should we do? Let's do Order Cloud. Order Cloud is Sitecore's commerce platform. So we have a lot of the commerce data stored in here aimed at developers. And you can see once I've searched changed the key phrase, it automatically updates with the content in there. So again, the bit with the blue background, the search terms, here it's trying to suggest extra key phrases to add on to help narrow down that search. Maybe I'm looking for Order Cloud environments information. Maybe I'm looking for the Order Cloud changelog. The piece with the white background is the top 6 results for the current key phrases. So we've got some examples coming from Sitecore Stack Exchange. We've got some coming from the Order Cloud documentation section. So you can see the Federated Search in action there. If I go and hover over these, you can see it automatically refreshes. So now we're seeing the Order Cloud environment information. We could go down and see Order Cloud's head start for headless e-commerce Mac architecture, if you want to get really specific. This isn't exactly what I'm after, though, so I'm going to go and do the full search. So I'm going to take my cursor back up there, hit Enter, and that's going to take me over to the full search page. And as I said, when you look at it as an end user, it's a pretty standard search experience that you will have seen in a lot of other sites. But the benefit and the power of it comes with how it's all built from Search's backend. So we can go through and we can start to look through the content here, and we can start to refine down what we're looking for. So we could, for example, say, I know, for example, I'm looking for sample code pieces. So I could go and refine this to GitHub repositories. This is going to give me all the different GitHub repositories that Sitecore have released related to Order Cloud. Maybe it's actually a video I want to look for. So you could go and, if I only click it once, you could go and also add videos in there as well. Looking over here, we have the different sorting options available. We default to what we've called suggested, which is basically letting the AI decide the sort order. It's going to take the key phrases, it's going to take other information based on how I've been interacting with the site, and it's going to make a decision on the order of the actual results that are coming back. We're letting it do its job at this point. But we have a couple of other options available. Maybe you want to sort by newest, if you know it's new content, oldest, or by title, for example. OK, can we go back to the slides? OK, so that's kind of shown quickly how we've implemented, well, how it works on the actual site itself. I want to talk a little bit about how it's actually implemented, though. So when you first start a search project, what you're going to have to do is you're going to have to build out your attribute definition. And this is basically a big list of all the fields you're going to want to index across all of those different sources that we looked at. And you can see here we've got some pretty standard fields you'd expect, so things like body, title, URL, images. We've also got different data types, strings, we've got integers, everything you'd expect to see in there. One of the things you're going to realize about this is, as I said, this is kind of the superset of all attributes across all of those index sources. A good example I like to think about with this is we index videos on YouTube. So one field you might want for that is an integer for the length of the video, so how long the video is. So you'd have a field in here for the length of the video you're indexing. That wouldn't really have much applicable information for a GitHub repository, though. You don't really have a length of a repository. It's not a thing. So you wouldn't use that attribute in the GitHub repository, but it's still populated here. The GitHub repository might have an attribute for the most common language in there. Maybe it's a C# mostly repository. Maybe it's a JavaScript-based repository. Again, that attribute probably wouldn't have any applicable to a video, a YouTube video, so you wouldn't use it on that one. So this really is a superset of all the different field types that you're going to use across all of your different sources. You can also see some checkboxes on the right, and those are basically how those different attributes get used. So you can see, for example, we do have some that are required. So they're going to be used on every index source. And you can see where some have been configured as a facet. After you've done this, though, you can then actually go and start to configure your index sources themselves. Did go over, there we go. So here you can see a screenshot of the different index sources that we created. This is about 2 months ago, I think I took this now. So it may be a little different when we look at it in a minute. But you can see we have a whole heap of different indexes or sources in there. And you get some really useful information, the number of documents in each of the sources. You can see the different types of connectors we're working with. Some are using a web connector, some are using an API connector, and I'll talk about that in a minute. You can see the status, which is pretty key. So you can see the top ones still being worked on. That's not live when I took this screenshot. And yeah, you can see all the information about the different sources you have running. That kind of shows how you're getting data into search, but you can also get a lot of rich analytics back out of it as well. So as the users are interacting with your site, you get to see what they're doing with search, which is really interesting. You can see common search terms. You can see whether search terms are increasing over time, whether they're decreasing over time. And then you can use that to make decisions on how you're going to implement changes into your site. So it's really rich analytics. I really like the keyword analytics. I find that's quite useful because you can actually see specifically what keywords are being searched for. And yeah, we'll take a look at that in a sec. I'm not going to dig too much into the development side of things today. I'm just going to call out that the dev portal is a Next.js site, so that's a React framework. And the search team recently released a React-based SDK, and that's what we use to implement this implementation. Excuse me. So it is available today. You can see the NPM listing for it there. It's only just been released recently, so we're still missing some of the supporting elements. The documentation's coming soon. We're going to have a storybook implementation coming soon as well to help show the different UI primitives. But if you're working in React or a React-based language like Next, I definitely recommend giving it a go. It saved us heaps of time in the implementation. OK, can we go back over to the demo again? Right, so I'm going to hop over to the back end of search. This is the CEC. So for anyone who hasn't seen it before, when you first log in, this is what you're presented with. And this is some basic overarching analytics around how search is being used on the dev portal. So we can see the visitors that have come in. We can see some information around engagement and how everyone's using the site. I'll come back to analytics a little bit later, though. First, I want to look at those setup pieces I was talking about. If we go into the admin section here, I'm going to go into domain settings. From here, I can go over to my attributes. And this is basically the screenshot that I just showed you before. These are all the different attributes that we have configured on the developer portal. You can see there's quite a few. We don't use all of them yet. Some of them, some other ideas that we're thinking about using. But you can see we have the attribute. We've got an attribute name and a friendly name. Moving along, the data type's pretty interesting. As I said, we've got strings and integers. You have the concept of a composite, which is like a JSON object. You can have arrays of JSON objects. So you can get quite in-depth with the data that you're storing for each of these index documents. The interesting bit for me are these tick boxes on the end, though. So as I mentioned, we have some required fields, so things like the ID. Obviously, you need an ID for each of your documents. We require a content type, so is this an article? Is this a video? Is this a GitHub repository? And we also require an index name, so where does it come from? Because we use that to build the facet out that we looked at. So we need to know whether this has come from the documentation side or whether it's come from YouTube or somewhere else. One that's really interesting that I like is this returning API response checkbox. So when we go and index all of these different pages across all these different sites, we index the entire copy, all of the content on there. Because when I did my order cloud search before, I want to do full text search. I want to search the body of all those documents completely. So that's why we have a body field at the top here. But you'll notice that's not checked with the return in API response. Because when I went to that full results page before, I had 24 results on the page. That's what we're defaulting to. If I was returning the body of all 25 documents in that API response, it's going to be absolutely enormous. So it's just going to really slow down the API call coming back. So we include the body content in the index because we want to search it. We don't return it in the actual API response to the front end because we're never going to actually display it out again. So that way you can have full text search across the full body of content, but you can still maintain the performance of your front end because you're just not returning that bloated data back over. You can see we have checkboxes for facets as well. So the facets we interacted with before on the site. So the content type is an article, a video, a blog, for example. We do have product set for some index sources, which we'll see shortly. So you can refine it by XM or XP or Order Cloud, for example. And then filtering is used to apply a subset of searches basically within certain sections. So if I was on the XM Cloud section of the dev portal, you could refine the results to only display XM Cloud results. We don't do that currently. We're trying to figure out the best way to use it, but it's a possibility that we're looking into. OK. So at this point, we've set up all of our attributes. So we need to go and create some index sources. This is where things get interesting. So we have a whole heap of index sources here, as we said. The YouTube API one is a new version of the YouTube one we're currently working with. So we have the YouTube one working currently. We're working on a different version. That's why it's not live yet. And you can see we've got some errors with it. We're still trying to get that one working well. But I'm going to look for a couple of these today, and I'm going to start off with a really simple example. And if I can just expand this out so I can see where it is. Somewhere we have the dev portal itself. Okay. You might be wondering why I'm saying this is a simple example. The dev portal is a simple example because it has a sitemap, which means it's really, really easy to crawl. On top of that, it is really consistent in where the data inside of each of the pages is located in the DOM. So every page has all its OG meta tags populated, for example. So we know we can rely on that data being there. I'm not going to lie to you, you're going to find that a lot of your sources are not that consistent, though. So when we get to a complex one in a bit, you'll see why that makes a difference. Looking through here, though, we can see how it's configured. If we look at the basic web crawler settings here, we can see we've configured an allowed domain to developers.sitecore.com. This is because, as we said, the developer portal is a shooting off point. So we have links to lots of content off of the developer portal. This index source itself is only used for data stored on the developer portal. We have a separate index sources for GitHub, for YouTube, for the documentation sites that will pick up those other pages. This index source here is only responsible for the small amount of content we have directly hosted on the dev portal. If we go down, we can see we have things like max URLs. You can set how long it takes to load a site. Parallelism is an interesting one. So when this site gets crawled, the parallelism settings basically define how many workers are going to crawl that site. And the easy answer to this is, more workers, quicker processing. And that works really well when you control the index sources, because you can expect, a big hit of traffic once a day when it gets crawled or something like that. When you don't control the site, it can get a bit interesting. We ran into issues with Sitecore Stack Exchange. Sitecore Stack Exchange is the biggest source of content we have on here. Second biggest is the documentation site. But we still think we have about 17,000 questions and answers in Sitecore Stack Exchange. It's massive. But as soon as we went past one worker, they rate limited us completely. So they just cut off all the requests and it wouldn't work. So we basically only have to have a single worker for Sitecore Stack Exchange, and we just have to take a slow crawling time. There's nothing we can do about it. We don't own that index source, so that's the price we have to pay for having that content, basically. You could configure things like whether you need to run JavaScript for the page to load and the content to be displayed. But when we get down here, this is where we actually start to configure things. So the first thing you're going to actually configure is what's called a trigger. And this is going to basically be a way for the web crawler to go and get a list of URLs that it needs to index. As I said, the developer portal is really nice because it has a sitemap. So I can take this, and if we just have a quick look in here, let's make that a little bigger for you. You can see we have a sitemap XML on the dev portal. This lists every page on the dev portal. So it's really easy to get all of the pages of the dev portal. We can make one request and get them all in a list. So that's all we need to do. We have different types of triggers here. We'll look at some others shortly. But you can make JavaScript requests. You can call RSS feeds. A request itself is where you'll just generally provide the home page. It'll download the DOM, and then it'll basically crawl through the DOM, find anchors in there, download those pages, crawl through the DOM, find anchors in there, and you can basically specify how deep you want to just crawl through the site. But as I said, the dev portal is great because it's super easy. Once you've configured your triggers, you're going to end up with a list. So we have about 120 URLs, I think, that comes back out of our sitemap for the dev portal. We then configure what's called a document extractor. And the doc extractors get run once for every URL you're going to index. And this is how you're going to populate those attributes we looked at. Again, the dev portal is easy because it's consistent. The content is always in the same location across the DOM, so we can run the same document extractor for every single page because the data is always in the same location. Because of that, we basically set a regex to match all URLs here. So this is going to run for every page, as I say. And then when we get down to the tagger down here, you can see we run some JavaScript to populate it. What I'm going to do is I'm just going to copy this into VS Code because it'll be a bit nicer to look at. Basically, this is the method in a JavaScript document extractor. You get this extract function with a request and a response that comes in, and that lets you work with the data to basically map it into these attributes. We're basically going to get the body of the document itself, and then we start just adding some logic in to figure out where this data is stored. For example, we go and check whether the OG image tag, the meta tag, has been populated on this page. If it has, we take the content for that, and that's going to be our image URL. If not, we fall back and we have a default image for the source. We generate an ID, which comes from the URL of the image with things like white space and special characters stripped out, which means we can have a predictable ID when we need to refer back to it in analytics. Again, the logic there is pretty straightforward. Once we've figured these out, we then just return this object, which is mapped through to those attributes we set before. So the ID attribute that we created, the content type, the type attribute. So these, everything on the developer site, is an article. That's what we class it as. Where we get the name from, where we get the description from. We have a priority attribute set, which again is something we're trying to figure out how to work. We've got this idea that some of our sources are more applicable to developers than others. So the dev portal itself is really like developer-focused content. But we also index like Sitecore.com. While Sitecore.com is a fantastic site, it's generally more marketer-focused content. So we're looking into how we can leverage these priorities to basically help to order the results to be more developer-focused. And then we have other fields like the image URL, image name, and the site name. And then down the bottom, that body attribute I was talking about. So here we store the entire text of the page in this body attribute. So for large articles, it could be enormous, definitely. And again, that's why we don't return it in the API response. OK, so after we've configured this, we can come out. And the last thing we need to do is we set up the scan frequency. So we're setting this to run basically daily at any time. We're not really fussed when it runs, but once a day is enough. I think we do daily for all our sources, to be honest. We don't have any like real-time information we need on the dev portal. But you can change this to be a bit more frequent if you want. You can run it all the way down to hourly. You can set it to only run for specific time periods as well. So you do get a bit of control over it, but that's not really a use case we have. OK. So let's start to get a bit more complex. I think the next one we'll take a look at will be the documentation side. So yeah, this is the big one, like 40,000 pages in here. It's enormous. So we have the documentation site again. It is a web crawler. Everything on there is stored on the doc site, so we don't need to actually restrict the domains at all. Things get interesting when we get down to the taggers section, though. So how the documentation site works is they don't have a single sitemap across all of the site itself. They have a sitemap per product, which is interesting. So what we have here is if we look at this, here we can see the CDP sitemap. So this is everything for CDP for developers, everything for CDP for users, and then there's another section which doesn't quite fit into those two categories. But that means we have to have 12 of these different triggers now. So we've got triggers for CDP, we've got triggers for XP, we've got Content Hub, we've got Order Cloud, and on and on and on across the whole product suite. So that's why we end up with a whole heap of different triggers. Each of those triggers is then going to return a set of URLs which are going to be processed by those document extractors. So you can see why this gets pretty large pretty quickly. If we look at the doc extractors, you can see this gets a little more trickier as well. We're not running the same document extractor for every single section of the documentation site. We found out different sections of the doc site will have the content in slightly different locations. So that was fun. If we look in here, we can see we're matching this through a regex. So basically, everything in the personalization URL will fire this document extractor. If we look in here, all the connect documentation, so we're looking for connect URLs, we'll fire this doc extractor. And then we've basically got a slightly different JavaScript object in each of these. So again, if I just hop this into VS Code to make it a bit simpler, it looks pretty similar though. You'll find that a lot of your document extractors do kind of follow this same pattern. We're storing the body of the response that came back. We do a little bit of logic here to basically strip out the title and the first two elements to get the start of the body of the document, which is what we then actually use to store the description, which is rendered in the search results page. And then we return out the object. Again, we're getting the title from the DOM itself, the description we just created, and setting the other fields. The interesting one we do here is, because we're refining this by the URLs to only be for Sitecore Connect in this case, it means we can now populate the product attribute. So now we know that everything for this document extractor is going to be for Sitecore Connect, which we can then use to populate that facet. So it means we do have product filtering only for the doc site so far. We're trying to figure out how to roll it out for the rest of the sources that we have. So that's 2 web crawlers. the last one I wanted to kind of walk through is an API crawler. And I figured I'd kind of ramp up the complexity as I went along. So we're going to talk a little bit about Sitecore's changelog here. So the changelog has an API endpoint that you can hit, for anyone who didn't know. And that allows you to go and get the data from there. So if I go down for the trigger in here, yeah, nice. So we're just using a request trigger at this point. So it's going to be a single request for this URL. And if I go and take a look at what this is going to give us, this is going to give us all of the changelog data in JSON format. So super handy. Anytime you can use an API crawl is really nice because it's really explicit what you're working with. You're not having to crawl through the DOM to find things. It's nice to just work with explicit data. So we can look down and we can see, we've got 133 changelog entries. And if we look at this entries node here, we can see each of these actual objects is one entry in the changelog. So this becomes really easy to map into our actual attribute because it tells us this is the title, these are the products we're using, this is the image, this is the description. So really nice one-to-one mappings for our attributes. Where things get interesting, though, is this end cursor. Does anyone know what an end cursor is used for, apart from Alistair? Next page, yes. So it's token-based pagination. So you probably can't read the URL from here. Or maybe you can on this screen. But we're only getting 10 results for the first page here. This end cursor, if I go and pass that in as the next parameter, it'll give me page 2. So the next 10 results. And it'll give me a different cursor. And I'll add that cursor on the end, and it'll give me page 3, and so on, and so on, and so on. So we need to find a way to be able to recurse through this result set, because we don't know how many pages there are. You could just do like an integer count if there's an integer paging, but that's not great because then you have to increase it as you get more content. We need to actually add recursion into this. So how the heck do we do that? What we do is we go down and we start off with the doc extractor because that first page of results has valid results. We've got 10 results in there, so we need to map those out first. So for that, again, we're using a JavaScript extractor. And let's move that into VS Code once more. And you can see here, it's slightly different because we're not working with a DOM anymore. We're working with JSON data. So we get the response data, but now we can just work with it as a JavaScript object, which is really nice. So we can basically go for each of those entries that we looked at, just iterate through, get me each of those, and we're going to return a changelog object. So we can get the URL for the ID, the type we know is changelog, and things like the title and description. They're all there. They're all part of that JavaScript object which came back from the changelog endpoint, which is really nice. So that's good. But how do we do that end token? Well, we have to work with what's called a request extractor. So what happens is when the trigger fires, that's one URL that basically goes and fires and gets its data back. Before the document extractor fires, it's actually going to fire a request extractor for that URL as well, if you have one configured. So what we can do here is, again, I'll move it over to here for you guys. What we can do here is we can read that body document and insert more URLs back into the list that's going to be processed by the doc extractors. So here, we get our response body. We're going, OK, do we have an end cursor? Because when you get to the end cursor is just not there anymore. So is that populated? Do we have more data available? There is. OK, so we're going to get the same URL as before, but we're going to add the cursor data on the end, which appends that cursor to the end to get us the next page. And then we're basically going to add that URL back to the list. Because that's a new URL in the list, that's going to fire the request extractor again. So then that'll give us the page 3 token. Then that'll go through here, that'll add a new URL, which will fire the request token. And there we go, we have recursion. Finally, we can go and get through all the pages of data that gets us right the way to the end of the changelog data. OK, so at that point, basically, you kind of have a lot of sources. We've talked about web sources, we've talked about API sources. There's kind of a bit of work getting involved in getting them all set up. But once you have that, you can then get search on your site. And as I said, once it's there and working, you get this rich analytics data that starts coming back. So we're looking at the last 7 days here. We've been live for a few months now. But you can start to see how the devs are using our site. So we can see like the homepage is the most popular, then XM Cloud Introduction, that's the next most popular, and search and so on. Scrolling down, we can start to see, which are the biggest gainers. So XM Cloud introductions, getting a lot more interactions. Same with XXA information. A lot of XM Cloud content, which is probably to be expected. As I said, though, the thing I really like is this keyword analysis, because here we can actually start to see what people are searching for. I'm going to change it to 30 days so we've got a bit more data. By default, it searches by the most clicked search terms. I like the most searched for, though, because you can really see what people are trying to find here. So we can see, like, XM Cloud, again, head and above the winners of all the rest. But you get some interesting ones. So community user profile Sitecore community. That's one of the most searched terms, which is interesting. I'm wondering whether it's a suggested one in that blue background area, and maybe that's why it's getting a bit more data. But it gives us really interesting information to be able to go and start to dig into why people are searching for this. Is it a problem with our information architecture? Are they struggling to find certain pieces of data? Is it missing data altogether, maybe? Like maybe we need to create new content to back this up. So this rich analytics can help you realize where you've got gaps in data location and even data existence, really. Okay, I think that's probably enough demo for now. Can we jump back to the slides? Awesome. So I'm just going to finish up with some tips and some challenges that we faced. So tips. The first thing we had is always refine your searches by source IDs. So we had that big list of sources in there. I didn't call it out, but I don't know if you noticed, each one has a unique ID for the source. When we first deployed the dev portal, we weren't refining by source IDs at all. We would just search every source that's there. And that works great for version 1 when you put it live. But what happens when you need to create a new source and kind of test it offline? As soon as we created it, the data just showed up on the live site, and we didn't want that. We wanted to be able to work offline with it, refine the data, get it to be how we wanted. So what you do is we set up an environment variable which has a list of the sources to search. So sources 1 through 10, we want to search only through those. So I can go along, I can create source 11, and at that point I can work offline, work on it locally on my dev machine, get everything exactly how I want it. When I'm happy, just go and change the environment variable, add source 11 in there, and then it goes live to the production site. So it gives you a nice separation of what's being rendered online and what you're working on offline. Request extractors for token pagination. As I said, if you need to add this recursion in for token pagination, Experience Edge works with token paginations. At any time you're going to be wanting to point search directly to Experience Edge, you're going to have to work with these request extractors. Took a little bit of time to get my head around at first, but once you figure out the recursion logic in there, it's a really powerful way to go and step through the data that's coming back. Configuring and or for search keywords. This is an interesting one. So by default, search will use an OR operator for keyword searches. So if I search for order cloud pricing, it's going to return documents that match order cloud or pricing. Ones with both will be surfaced to the top, obviously, but lower down you'll get results which are only order cloud or only pricing. You can change it to be an AND operator, which is what we've tinkered with, and you get a smaller set of results, obviously. However, you'll run into issues with spell checking. So if I spell order cloud and then misspell pricing with an AND operator, I actually get 0 results because there's no documents that match the misspelled pricing keyword. What we're thinking of currently is we want to add the AND keyword, but we're working with the spell checking algorithms that are built into search to then have a suggestion on the no results page. So you get better results from AND, but then if you misspell something, you'd land on the no results page and it'd say, hey, you misspell pricing with a link to go and search for the proper spelling of it. Conditionally include your widget provider. So I didn't go too much into the SDK today, but basically, as I said, it's a React-based SDK, so you get a lot of components to include in your application. To get it to run at all, you need to wrap your whole app in the widget provider component, and it works on a series of API keys search to basically get its data in and out. So if you have a lot of devs working on it, they may not all have those API keys. So it's a good idea to basically conditionally include that widget provider component, because then you don't get any errors about missing API keys. And if you download the dev portal, it's all open source. You can run it all locally. You won't have the API keys for our search instance. So when you run it locally, you'll just get a bit of text saying, you need to populate these environment variables to run search, but you don't get any errors or anything. It's a graceful fallback. Okay, challenges, yeah. I had a really good time working with Search, but it definitely took a little bit of time to get my head around some of the concepts. Debugging index failures, that was probably the trickiest one. So we're working on getting better UIs for that. I think I hovered over one of the errors that was showing up before. There's going to be a full UI where you can dig into all of the index crawls that happen, get all the errors from each document that failed, because those JavaScript objects that we were creating, the JavaScript logic we were putting in there, if there's errors in there, you need to know what those errors are to be able to debug it. Currently, when you start a search project, you'll be assigned a technical account person, basically, who will help you out, and they will be able to get that error data for you, but we're working on exposing that data out in the future. And it's pretty soon, it's not far off. The next two are kind of related. So refining crawlers, refining document extractors, token extractors, it takes a little bit of getting your head around. Like the first 2 or 3 you work on will take a little bit while you're learning, where's the typical place I get this data from? How do I work with sitemaps and XML maps and RSS feeds and things like this? The more times you do it, once you're doing your 6th, 7th, 8th source, you kind of can rattle them off a lot quicker. But the first couple you're going to work on, it's going to take a little bit of time for you to learn how the platform works, how you get the data, where you're meant to put your logic, where you're meant to basically set up these attributes and everything around it. The final result, yes, was search results limiting. So search has a hard limit of 10,000 results. It'll never return more than that. But there's good reason. So I spoke to the product team about this, and the way they describe it was the further through the data set you get, the less concrete the term matching is. So the results you're seeing aren't exactly matched through to what you searched for. The thinking here is you don't want your users to be just hitting through to page 472, because that's not a great search experience. Really, what you want them to do is to go and refine their searches, use faceting, use sorting, and then get the data set down to the smallest size possible, and then use pagination as the last resort, basically. But the idea is to use the other tools in their box to try and get to the results first. Okay, and I think with 5 minutes left, that was everything I had to talk about. There's a lot of social things here if anyone wants to get in touch, but yeah, we've got 5 minutes if anyone has any questions. Okay, do you have a mic anywhere? There's one over there, there we go.
Use with XM.
Sorry?
XM. How you search with XM Cloud?
So search is completely platform agnostic. So we are using, the dev portal is actually just a set of markdown files, basically in an XJS application. We're crawling that for the dev portal. We're crawling YouTube. We're crawling all those different sources you saw, basically. For the front end, we have an SDK for React-based implementations. So if you're on XM and you're in JSS and React, you could do that. If you're not, then there's a full API that's available. So there's a full REST API where you can go and you can build the exact same experiences we did here. You're just manually calling the API, pass the requests over, and get the data back.
Okay, fine.
Through the middle there. Up behind you, mate.
All right. So is there any option for this spelling check stop word?
Yes, so that's what I was saying. We're working on it currently. We have it working for spell checks if there's a single key phrase. So if you do one word and spell it wrong, we're still trying to get it working with multiple key phrases. So we are using the OR operator instead, because then you pretty much never get 0 results. Once we get the stop word spell checking working across multiple key phrases, then we're going to switch over to and basically surface spelling suggestions for errors. They're working on it, basically.
So it is something like suggester, which we can be shown on the search text, right?
Yeah. So basically, everything I show when I was doing the searches, it's a request over to the search API. We get a JSON object back. That JSON object that comes back has things like syntax highlighting. So when the search results are displayed, it'll highlight the key phrases in the search results. One of the options that comes back is spelling suggestions. So when that response comes back, it'll have a list of spelling suggestions, and then you just render that out to your application, however your UX kind of fits it.
Thank you.
It's down the front here. Oh, at the back, yep.
So how much time or effort was needed to implement this?
Sorry?
How much time or effort that went in to implement this?
How much time?
Yeah, duration, basically, duration of the project.
Oh, division of the project. It was pretty much just me, so 100%. I wasn't working on it 100%. That's kind of how we work in the advocacy team. I think I set up most of it in a couple of weeks, maybe, working on and off. Again, I was working pretty closely with the product team, so they helped out a lot. But I think you could stand up a search instance fairly quickly with one index source. Yeah, I don't think it would take too long, really. The interesting part comes when you're tweaking the data, getting things right. You know, once things are live, you search, and then you're like, okay, I'm not entirely happy with the search ordering, so you may work on the back end with how the different attributes are being matched for the search relevance. Getting it live, I think, is actually pretty fast, but then tweaking it afterwards is where you can spend time just getting it exactly how you want it, really.
Okay, okay. So I think it will also depend on the number of sources that you have. Number
Oh,
of data
100%, yeah. That's what I'm saying. So you could get a site with one source up and running very quickly. If you've got, 12 sources like us, it takes a fair bit longer, yeah.
Sure. Thank you.
Hi, this is Vivek from LTI Mindtree.
Aye.
Now, we have seen number of sources to be crawled by with the Sitecore Search. What if one of the source is down? Are we maintaining any kind of cachings or offline data?
So basically, we set up for a daily rescan. So basically, once a successful scan has been completed, that index is built and it's available to search on the front end if it's included in our environment variables. If the next day when a scan happens, if it fails halfway through, it'll use that existing index. It won't replace it with the failed index until a completed index scan has happened.
Okay, thanks.
Hi, Harinder
Hi.
Harinder from Altido. The search box that we have actually on the bottom, on the first page, isn't giving the results for the partial search results, or for example, I'm passing order cloud. Instead, I'm actually just passing order. Is actually going to give me the whole result set, or just I have to pass order cloud and then only it's actually giving me the whole result set?
So it'll give you different, as you type, it'll update, basically. Yeah, is that kind of what you're asking?
Yes.
Yeah, so there's a delay. So there is a slight delay where not as soon as you push it, I think a couple of seconds maybe, just because it needs to wait for the end of the word. But yeah, as you're typing, it'll perform the search for you and update it. Yeah.
Okay, and do I have to put the whole word for the search results to get the whole search result, this preview search passage to give the result set, or is it just look for order and not the order cloud?
So it wouldn't find order from order cloud. It won't do subwords within a word. It only search for whole word, the whole word key phrase you enter, basically.
Okay.
Yeah.
Thank you.
Hello.
I think we've got one more question maybe, and then we'll call it a day.
Hey.
Hi, this is Madhur from Altido.
Yep.
So in case of search, do we have an option for setting the boosting, the priority or the preference for one field over another?
Yep, so the attributes we are searching for, well, basically, when you do a search, we search the name, description, and the body. We have the name as the top priority, because if a key phrase is in the title of the document, then that's really important. And then description and body are second, just below that. So you can basically boost and bury each individual attribute to say, preference, basically, yeah.
So can we change this preference order or?
Yeah, that's all configurable in the CEC. You have complete control over that. Yeah.
Okay, and how about if we need to perform some operation, can we have something like custom index that we do in other searches? Create our index, custom index. If you want to do some manipulation on the data before we are pushing the data to indexing.
So you wouldn't do it, you wouldn't do the customization on the index itself. You'd do the customization when the data goes into the index. So the customization would happen in your document extractor, in your request extractor. That's where you build the object that goes in the index. So that's where you'd put your custom logic.
But it might increase the, it might impact performance, in case when we are searching for something, it's better to have the data, manipulated data sometimes, right? So if we are performing operation after getting the data, then that calculation will take some time. So better would have been to push the data in a way that we can do massaging before pushing the data to indexing. So is it something possible here?
Not really, no. So once the data is in the index, that's the data you get back out of it. You can change what's boosted and buried and the importance of the fields that the searches perform, and that's all fine. But yeah, if you wanted to add custom logic, you'd add it at the moment the data goes in. Yeah. Does that make sense? Have I understood your question properly?
Yeah.
Yeah? Come and see me after, if not, and we'll talk about
Sure,
it.
sure.
Okay, I think that's probably all I've got time now.
One
Thanks a
more
lot.
question. Like in case of end cursor, like is it a pointer or like the number? Like can we in the end point cursor, can we give number like give me 5th page result, something like that? Is it possible for
That could-
paging?
That completely depends on the API you're calling. So the API for the dev portal, which we looked at, has a page size and a cursor. It depends how your API is configured. You can call whatever you want from the JavaScript. It depends on the source configuration.
All right.
Okay,
Hey
thanks a
Rob.
lot, everyone.
Hey Rob.
Thanks.
Rob. Excuse me. Sorry. I just have a question.
Come and see me after. I don't think we've got time. We've got to get
Sure.
the next session on. Yeah.
Sure.
Cheers.
I'll do that.
Thank you.
Thank you.